Hello, international students.
Yeah. Okay, so whoop, got another arrival here. All right, so a couple things. You can see the reminders down at the bottom, which may be the most important part of the agenda list here. The Positive Physics Assessment Unit 23 is due tonight. So I've been talking about that every day the last week or so. Actually, it was opened before spring break, so it's been available for a long time. Hopefully, been working on it. I know some people are finished with it. Remember, tests are 40% of your grade, so you want to make sure you do well on this. We're going to probably have around 25 minutes or so at the end of class today that'll be just for you to work either on that or on other things. And you can ask me questions about it, but because it's a test, not a worksheet, not a homework, not something like that, I'm a little bit less helpful. So I might give you a hint, but I might also say, sorry, I can't tell you that because it is a test. I want to see what you can do. And so it's also one that I would prefer you not really work together with people as much on it. I mean, if you have, I'm not going to worry about it, but I kind of want to know what you know. That's the goal of an assessment. And it's cumulative because it covers everything we've learned this year at a fairly basic level. There's a few challenging questions, but make sure that you are getting that done tonight because that is technically worth more than your final. So you want to make sure that you're doing well, finishing it completely, getting it turned in. There's 30 questions. So if you haven't started it, make sure you invest some time today to get that done by 11:59 p.m. Pacific tonight. Do you have a question in here?
Oh, no.
Oh, okay. All right. And if you haven't started it, I would like you in class today to verify, this is point number 1 on the agenda, verify that it is unlocked. So go to Positive Physics, make sure it's unlocked. If you've started it, you know it is because you've already been working on it. But if you haven't started it, make sure it's unlocked, make sure you can get to it because if not, then I need to go through a couple of steps to get it unlocked for you. So far, it's only happened to 2 students out of almost 70. So I don't think it's going to be a big deal, but if you're one of those rare cases, then I want to make sure we get it fixed for you. All right, the second thing is I just want to very briefly confirm that I have the correct numbers for who's taking the exam this Thursday, online versus in person. Remember that you can see down there at the bottom under the other reminders, this Thursday will be the FRQ portion. There are 4 FRQs. There are 2 long and 2 short. The order will be short, long, long, short, because that more follows the order that you see on the traditional College Board exam. So I want to mimic that as much as possible, but only 4 instead of the typical 5, because we only have 80 minutes instead of the typical 90. And so when you come into class on Thursday, because most of you are planning to be here, when you come in, there will be seats set out with a test with an AP formula sheet. You'll need to bring a charged calculator and then some paper to, or so, pencils or pens to write with. And I'll have some scrap paper, or you can use your own. And then I'll have some answer paper, some lined paper that will be your answer sheets. And you'll need to use the answer sheets. So you can write on the test packet if you're here in class, but that's not what I'll be grading. What I'll be grading is your answer sheet. So make sure everything, and it'll be on the screen to remind you of this, but make sure everything you write is on the answer sheet. Now, if you're taking the AP or taking this online on the AP classroom, then it will all be in the AP classroom and you'll have to type everything in. It is a lockdown browser scenario. So when you log into it, you're not going to be able to open up other tabs. You're not going to be able to copy and paste things in. So you'll need a print version of the formula sheet because you won't be able to, once you're in that lockdown browser, you won't be able to like open up other tabs and see the formula sheet. So you'll need to have a print copy if you're doing that online. If you are in class, you can choose to do your answers on the AP Classroom site if you'd rather type them instead of write them. But I will have basically lined paper is your answer sheet for this exam. All right. And it'll just be like notebook paper for you to write on. Okay. So any questions about that format before I just quickly confirm who's going to be here and who's going to be online? All right. So I don't see, oh, Jack's a senior, so he's at senior day. I assume. Ethan, you're planning to be here,
I am.
and Nat, you're gonna plan to be here? Right, okay. Evan, you're planning to be here, Kyle, same?
Yeah.
Johnny, same, here? Okay. Aiden, same? All
Yeah.
right, Andy? Hey, Rocky, you're gonna be planning online, right? Okay, so you'll still come into Zoom, and then I'll give you final instructions as we activate the AP Classroom. And then Sally, you're planning to be here? Okay, and then Cade planning to be here? All right. So no changes on that front. Then next Monday, it'll be the multiple choice portion. And the multiple choice portion has 42 questions, 40 that are normal, 2 that are multiple correct. So 2 of the 5 options will be correct, and you'll need to pick both of them to get it answered correctly and earn full credit. There isn't any partial credit on any of the multiple choice questions. And it will be entirely graded on and submitted on AP Classroom. So next Monday, whether you're at home or whether you're here next Monday, you'll all be taking the multiple choice part on the AP Classroom site. All right, so just keeping that in mind. So today I want to do a quick overview of showing you the AP Classroom site in case you haven't been using it very frequently. We haven't really had almost no assignments there. There was a one I asked you to watch some daily videos and such, but it wasn't even a graded assignment. So and early in the year, the site was still, a lot of changes were being made. And then they still haven't updated the units that got cut. So I've been a little hesitant to use it a lot, although they have been making a lot of improvements through the year. So there's a lot of good things. So let me change the share and let's look at that together. Probably going to make me go back to the home here. Probably going to make me log in again. Oh, no. All right. So one thing I want to show you, this is my version, the teacher version. There's a lot of things that are similar, but there's enough different that I would prefer to show a student version if I'm allowed or given permission. So is there someone either in the Zoom or in the classroom that would be okay with me using your account?
Use mine.
Andy, okay. So it won't show any of your grades or anything if you've done some work on here. So let me just go to student view.
I don't think I've been on that website
That's fine. Section 2, and then there we go. All right, so this will be more like what you've seen. In fact, if you've got your computer, whether you're here or in Zoom, I would encourage you, get on the AP Classroom right now. Make sure you can, make sure you know what to do. So if you haven't been very active on here, you'll probably get this welcome sign. And then you can just click watch later. And I'm going to minimize this so it doesn't cover up anything for now. And then this up here, this gives you kind of a map to what you can do. And it goes on and on and on, but primarily right now it's showing you, hey, watch some daily videos. And so that's its recommendations for you. The main recommendation that I would want to highlight is this very first one, YouTube live stream. And so if you click on this, it takes you to a YouTube page.
It's a live stream of people doing physics 20%.
And it will be every day, Monday through Thursday at 3 p.m. I'm assuming that's 3 p.m. Eastern time. I don't know for sure. So that means it's noon here, if that's correct. So you probably can't watch it live, but they do post them after they do record them and post them. So you don't have to watch them live. But you can see that today, the 19th at 3 p.m., they're showing how to understand motion and kinematics. Last year, these were like a 20, 30-minute review where they did practice problems. They talked about lab implementations, really good stuff. And then tomorrow, they're doing another one on Newton's 3 laws of friction. Wednesday, they're doing circular motion and gravitation. So those would be the 3 that you could watch and review with before we take the FRQs on Thursday. Thursday, they're doing work and energy. And then next week, they're going impulse conservation, simple harmonic motion, rotation. They're doing a couple on rotation here. And then there's some things on units 9 and 10, which probably won't be that helpful since those are no longer part of the exam. But that's a great resource. I felt like these were maybe the best bang for your buck in terms of reviewing last year. Now, obviously, I haven't seen this year's because they don't start till this afternoon. But last year, I watched every one of them, and I thought they were really high quality, really good stuff. One of the main speakers for AP Physics 1 is the author of the 5 Steps to a 5 book, who also helps write questions for College Board. So I mean, who else could you ask for a tutor that's going to tell you better stuff than that guy, right? So great research. Now, I don't know if he's doing these videos this year or not, but last year he was the primary one and he was really good. He's got a very eccentric personality, but he was really good. All right, a couple other things. Down underneath here, you can see all these units. So under the course tab, there's all these resources you can download and look at. There's a workbook for practice. Here is the actual constants and equation sheet. You can get it off the Access page, but you can also get it here. Down here are lectures on every unit except for Unit 1. Not sure why they didn't have one for Unit 1, but these are faculty lectures by college professors from a variety of different universities. Don't worry about 8, 9, and 10. I think these arrows are saying these are the ones you should watch because Units 8, 9, and 10 got canceled this year from the exam and actually will be no longer a part of the course going forward either. So just focus on these 7 if you want to watch those faculty lectures. If you go to Unit 1, you can see it's about kinematics and you can see all the daily videos. There's 8 daily videos on these topics. There's 6 daily videos on these topics, and every unit has that same kind of pattern with daily videos on all the different topics. And then also down at the bottom for every unit, there's multiple choice and free response practice, these progress checks. If you complete the progress checks, at least for the multiple choice, I don't know about the FRQ. I don't think these FRQs are allowed to be self-grading, but for the multiple choice, if you complete them afterwards, it takes 10 or 15 minutes usually to get it processed. But then if you go back on, it tells you the correct answer. It shows you obviously what you picked and whether it was right or wrong. It links to a video that helps explain why the answer is what it is. And so it's got a lot of feedback for you. So those are great multiple choice questions to practice. And they have them for every unit. Now remember, don't worry about units 8, 9, or 10. We didn't cover them because they're not on the exam. There's also this review tab, which right now basically has nothing, but I think over the next weeks, they're going to be adding more and more things. I think actually these AP videos that are on YouTube are also going to end up here as well, although I'm not certain of that. And then the last part that I want to show you is if you go to the assessments tab. Now, like I said, I haven't had any assessments that you had to do yet, but if you're taking it online this Thursday, and all of you will be taking it online Monday for the multiple choice, this is where it'll show up, is in this assessments tab. And all of these that are here as assignments are topic review multiple choice questions. So you can do the ones that are on the unit pages, or you can come here and find even more. All right. And so I've made them. I was initially numbering these according to the assignments in my online class at the beginning. And then I switched that because I realized it'd be a little bit confusing for you guys that are not in my online class. So you can focus on the number that's at the end. This is chapter 7, part 1, chapter 7, part 2, and so on and so forth. All right, so you can see all the first 7 chapters have topic questions that you can practice. And then if you really want to do some multiple or some free response that you can self-grade, on Andy's at least, the second page, it's the very first one, practice FRQs, because they're in alphabetical order. Practice FRQs for 2021. I compiled 54 FRQs that cover basically every topic we've learned and could be on the test. Not every possible question type, but every topic. And they're all self-gradable. Obviously, you can't do 54 FRQs between now and Thursday, but you could do some, and you can self-grade. All right. So, and then here's also links to those progress checks that you can get it from the unit or you can get it from here. But those are the things. Now, any questions while we're on the student view of where you find things or how to use what's there? All right. My number 1 recommendation is practice any way you can, multiple choice and FRQs. So obviously for Thursday, focus on FRQs. For next Monday, focus on multiple choice. And my second highest recommendation, watch the review videos that start getting posted this afternoon. You'll get 3 of them before Thursday. You'll get 4 of them before next Monday. I think those will be great reviews. All right, now let me go back to my view to show you what you'll be seeing Thursday and next Monday, because they don't show up on yours, so I haven't published them to you yet. But on my view, it's a little bit different. So I got to go through quite a few little hoops here to get where I need to be for you guys. But all right, so these are some things that I have not assigned to you yet, including your semester 2 exams, which are right here. Okay, so on the FRQ. Like I said, there are 4 of them, 2 short, 2 long, in the order of short, long, long, short. And so I will have those popping up at the beginning of our class, staying open for, I'll leave it at 80 minutes, even though technically you're only supposed to get 76. We'll try to start right at the normal 10:05. So might want to try to get here just a couple minutes early so that you're not rushing around and losing any time. And then we'll go right to the end and then it'll shut down. Now, if you're taking it in class, you won't have to use the AP Classroom site on Thursday for the FRQs, but you may. If you'd rather type your answers, you can. So bring a device if you want to do that. Otherwise, Thursday, you can do it all on paper. Next Monday, everybody will be doing it on this site. So that's the multiple choice next Monday. All right. So that's the titles you'll see when you're looking in your assessments tab Thursday, if you're doing it online, and Monday for everybody. All right, any questions on the exam prep, AP Classroom? One thing I would suggest as a recommendation for review is try to be intentional. Don't just skim a lot of stuff and kind of learn nothing. Focus in, especially pick a couple topics that maybe you feel the least confident in, and just practice an FRQ or 2, and don't give yourself so much to do that you cannot possibly do it, and then you just get discouraged and quit. Those are the 2 things I see. Some students just kind of skim over a bunch of stuff and they don't really learn much from any of it, or they say I'm doing 72 FRQs, they get 2 into it and then they get burned out and they give up, and so try to come up with a realistic goal, be real intentional, pick the topics you think you need the most review, and just practice. That's my recommendation. All right. So back to the agenda here. We are going to work on FRQ from Unit 7, but I do have ones for Unit 6 printed now. It's taking me a while to print stuff because I have to go over to the other building. Our printer downstairs is having trouble stapling and stuff. It keeps jamming. And so I do have not only the Unit 7 one that I had last week, I also have one for Unit 6 here now. We're just going to do one from Unit 7 today. But if you want a paper copy of Unit 6, you can grab it. If you are in the Zoom, you can find the Unit 6 one on the AP review sources on Axis. So the very first topic that says AP exam resources, it's on there. Actually, let's go back there and make sure you see what one we're doing today. All right, so just make sure you know where to find this. When you open up to the bulletin board page, go to topics. And it's this one right here, the very first one, AP exam resources. That's where you'll find it. If you click and just scroll down the bottom right-hand corner, there's all kinds of good stuff here. Bottom right-hand corner, there's the new one for Unit 6. And Unit 7 is right here. This is the one we're going to look at. All right, so Unit 7 is the one we're going to do today together. And you're looking at the right one if this is what it looks like. 7. This question is a short FRQ. Show your work for each part. It's about this puck sliding into a horizontal surface. Make sure you guys are seeing that. So you guys seeing the FRQ on the screen now? So this is a short one. So you're supposed to be able to answer this one in 13 minutes. And so that's what I want to give you is 13 minutes. And after that time, we'll have you check your work and then we'll have some conversation. And then after that, we're just going to have time for you to choose what you need to do. If you need to finish up the positive physics test that's due tonight, or if you need you've got that done and you just want to review, you're going to have some time at the end of the day today to just your choice on how you want to invest it. But for now, it is 10:26, so we'll go to 10:39. Probably let's go to 10:40, so it's a nice easy number to remember. And you're already a few seconds into it. So at 10:40, we'll start checking this question. Good luck. So in that 13 minutes, you should have felt the amount of time that they expect you to be able to answer all parts of this question. So it kind of helps you predict the pace that they're expecting for the FRQs. What I want you to do now is take another 4 or 5 minutes, look through the scoring guide. So for those of you here in the classroom, you just have the test booklet in print. So you'll have to look on the Axis under the resources. For those of you that are already on Axis, looking at it under the resources, you've got the scoring guide. But for those here in class, you just have the printed of the question. So you'll have to look on Axis under AP resources and then take, like I said, 4 or 5 minutes, read through the scoring guide, evaluate how many points you think you would have got out of 7, make any notes of questions you want to ask, and then we'll have some conversation after those few minutes about what your results show.
This was just question 1, right? Not the.
Yeah, just question 1.
Okay.
Yeah. So you should be able to get that short one done in about 13 minutes. All right, hopefully you had a chance to look over and evaluate your answers, see what you think you might have earned out of 7. I would say if I were ranking this question in terms of difficulty level, it's kind of interesting because in terms of topics, I would say rotation and angular momentum and those kinds of things, probably the hardest topic of the year. In terms of just the fundamental difficulty of the FRQ, not considering the topic at hand, I would say it's kind of a middle of the road FRQ difficulty wise. So it may feel hard because you struggle with rotation, but if you know rotation well, I would say it's like midway. So if it felt really hard to you, then it might mean you need some more review on rotation. If it felt kind of middle of the road to you, then you're probably pretty comfortable with rotation. Yeah, Andy?
I looked at it as like a momentum problem.
It is, but it's rotational momentum, or at least it has rotational momentum, because that's what they want you to graph is the angular momentum.
Oh,
So, all right, so if we look at the question here, it says we've got 3 scenarios. In every case, we've got a puck hitting this rod that starts to pivot. There's no friction, so the rod just, once it starts moving, it's just going to keep moving. And in part A, it says we're supposed to graph the 2 quantities as a function of time. And the first one it wants you to graph is the angular momentum of the puck. So if we look down at their graph as the example here, oh, I think I went too far. Nope. There we go. We can see that the puck, you guys are seeing it on the Zoom as well, right? Okay. We can see that the puck has a probably positive. I mean, it doesn't technically have to be positive, but most often I think we would think, well, it's starting with positive momentum. And then it ends up going the other direction because we're just looking at scenario or case 1. We're just looking at that first scenario. So the puck starts with a positive angular momentum and then ends up having a negative angular momentum. Now recall, when we were learning this lesson, we found out that objects moving in a straight line can still possess angular momentum. And that sometimes throws students off. They want to say the puck has no angular momentum because it's not rotating. But remember, we actually did a problem back when we were going through this unit where we discovered both conceptually and mathematically that objects moving in a straight line do possess both. As long as they have the ability to collide with something and generate angular momentum, they must possess it themselves. So in this case, that's what happens. So even though the puck's moving in a straight line, it possesses angular momentum. Now, technically, you could have made it negative and then end up positive if you wanted to say that its initial direction was the negative direction and its final direction was positive. That's fine. The key is that it must start out on one side of the zero and end up on the other side of the zero. So the puck's graph is starting here at +3 and then ending up at -1. Now for the rod, it was stationary at the beginning, so it wasn't moving at all. So it had no momentum of any sort since it had no velocity of any sort. But after the puck collides with it, the rod will start to move with angular momentum. And because momentum is conserved, however much change there was in the puck's momentum, that's how much change there has to be in the rod. So if the puck went down, and you don't have to have it at 3 and -1, you could have it 2 and -2, you could have it start at -4 and end up at -2, like you can make it whatever you want, but whatever amount the puck changes, so in this case, the puck went down 1, 2, 3, 4 levels. Therefore, the rod has to go up 1, 2, 3, 4 levels because momentum is conserved. Do you have a question, Evan?
Yeah, it says, so for the first point, it says, 1 point is earned for a labeled graph of the puck. It's the first point. It just says that afterwards, it has to be smaller in magnitude. The puck's momentum, but you were saying that if it was 2 and -2, it would work.
Oh, yeah, I guess
So
2
would
and 2 and -2 won't because it's not a perfectly elastic collision.
Okay.
So,
That's
yeah,
what I
so
drew.
you did have
I
2
did
and
2
2?
and -2,
Okay.
yeah.
Yeah, that's, I forgot about that. Yeah, it can't actually be equal. I was just trying to emphasize that it would have to be on either side of the zero, but yeah, you're correct. It can't be actually the same value. It has to have less magnitude after. So wherever you start with, it can be any amount less because we don't know enough quantitatively to be able to calculate it. But yeah, it's not a perfectly elastic collision. And so there would be less momentum afterwards, just in the negative direction or the opposite direction. Yeah, good question. The second bullet point talks about the fact that however much the puck lost, the rod has to gain. And so you have to show that transition correctly. Anything else about part A? All right. For part B then, it asks us to figure out, see, how does it rank the magnitudes of the angle that the rod would go through with the various scenarios. So I'm going to switch from this one. You can read the key there, but I'm going to switch to, there we go, this screen. And here's how I would recommend you try to think this through. It says rank the magnitude of the angular displacements, which is theta. So you can see that they're showing θ1, θ2, θ3, and they're saying it's going to be measured over 2 seconds. Well, once the puck hits the rod's going to be moving at a constant velocity because there's no friction to slow it down. So once it starts moving, it's just going to be continuing to move. So it's not like we have to worry about it stopping before the 2 second mark. It's going to still be moving. And it wants us to rank which one has the greatest angle in 2 seconds versus the next and then the next. And so since it's the same time for all of them, we can conclude that whichever one has the rod moving faster would have the greater angle because they're all going for the same amount of time. So we need to figure out which one would have, in which cases would the rod be moving the fastest. Now, one way to process these kinds of questions is to recognize, well, they're asking about angular momentum. So where's angular momentum on my formula list? And there's 2 angular momentum equations. If you forget what angular momentum is, look in your list, capital L, angular momentum. Down here, L equals L equals. So we've got 2 formulas that have angular momentum on the list. And so that's my recommendation. If you're not really sure how to get started, start looking at the formulas. And okay, well, will either of these formulas help me figure anything out? Well, logically, the one that's moving fastest goes the farthest in the same amount of time. So which one of these has a velocity in it? The left one or the right? I mean, which equation? The left one or the right one has a velocity in it?
Left.
The left one. This is torque times time. That doesn't tell me anything about velocity. It could be helpful, but this one has velocity in it. So if I can use this one and figure out, oh, which one's fastest, the fastest one goes the farthest distance in the same amount of time. So if we think about this, what's the I?
They're all the same.
What does it mean?
Oh, it's the inertia or the mass times length. There's some other things.
Yeah, it's rotational inertia. And rotational inertia relates both. Whoops. Rotational inertia relates both the mass and the distribution of that mass. Remember, when something's moving in a straight line, the inertia is just based on mass alone. But when something's rotating, it's both the mass and how the mass is distributed. The farther out the mass is from the center, the harder it is to accelerate. The closer the mass is to the center, the easier it is to accelerate. And sometimes there's, depending on the shape, sometimes there's a 1/2 and sometimes there's a 2/5 and a fraction or whatever. But at least we know that it's related to mass and how far the mass is from the center. All right, so those are the things we want to be thinking about. Now, Andy said, well, I just thought about it as a momentum problem, and it is a momentum. It's just angular momentum. So we can think about the change in momentum for the puck, because the change in momentum for the puck has to equal the change in momentum for the rod, because momentum is conserved. So if we think about the change in momentum for each one, the larger change in momentum, and Ethan made a good comment that this I value stays the same in the first two cases, like the rod doesn't change at all. So if we just look at case 1 versus case 2, it's just a rod. So whatever the I is, it's going to be the same for both cases. So if we think about the change in momentum here, in the first case, the puck, and this may help, this process may help some of you if you're struggling to see that this one going that direction and turning around and going the other direction means it's got basically double the change in momentum of this one. And some of you might just be able to recognize that right away, but if that doesn't make a lot of sense, just put some numbers to it. Just say, let's just say that mass is 1 kilogram and the initial velocity for the puck is 5 meters per second. Just make up some numbers and keep it consistent throughout. Now, don't base your answer on the numbers, but the numbers can help you process what's going on. So what's the momentum of the puck in the initial, if these are the values, where, well, the initial would just be 5. Why is it erasing all of a sudden? Okay. Let's go back a screen. It's weird that it's freaking out on me like this. Haven't ever had this happen before.
First time.
Okay, good. What's the final momentum when it's going the other direction?
Negative.
-5. Seriously. All right, so the change in momentum would be final minus initial, -5 minus 5. Holy cow.
Now this is
Okay, let me try something here. Open it back up and see if that's gonna help. First time I've ever had this happen.
wow, the owl is really moving.
Unfortunately, this is one of the programs that takes the longest to open too.
Not that it's
All right. All right, so
really find it.
let me scribble some things down here real quick. Things we've mentioned already. So
Where are you screen sharing?
Oh, sure, thank you for reminding me. I forgot, we were before, but we're not now since it's shut down. Okay, so let me try to catch back up here real quick. All right, so now L. Thought it wasn't gonna work again. So we know at least those things are gonna make sense. We also know change in momentum for the puck has to equal change in momentum for the rod. And we know if we say mass equals 1, I'm not even gonna worry about the units for now. I'm just gonna give those just so we can hopefully make it work.
Yes, it worked.
Made it through one whole thing.
Yeah.
Let's
All right, so
go.
in scenario 1, if we just make up these numbers, we see that it's gonna have a change in momentum of -10. All right, so let's compare that to scenario 2. In case 2, what's the initial momentum?
5.
If we use the same, we want to use these same values.
5.
5. And then what's the final momentum?
0.
0. It comes to a stop. Yeah, good. Someone on the Zoom also chiming in. Good. So 0 minus 5 means the change is -5. So if I'm comparing case 1 and case 2, which one has a greater change in momentum?
Case 1. Case 1.
Case 1. If the change in momentum is greater and the I is constant, in other words, if this is going up and this is constant, this has to go up. So case 1 will be moving faster. Therefore, it will cover a greater angle in 2 seconds. So now we know that case 1 is greater than case 2 in terms of the angle because it's got a greater velocity. Tracking okay on that? So if you weren't really sure how to process this, this is one way to do it. Now, in the second case, or the third case, it's a bit different because now the puck sticks to the rod. So now that the puck is sticking to the rod,
It's going to
this I value is no longer change or no longer staying constant. Because now it's not just the mass of the rod anymore. Now it's the mass of the rod and the puck stuck to it. So in this one, that I value, the mass went up. The radius, the shape of it didn't really change much, but that means the I has to go up, right? So if we think about our L equals I omega, momentum's conserved, so that can't change. That has to stay steady. If this goes up, that means this has to
go down.
Go down.
go down. So that means it's moving slower. If it's moving slower, it's going to go less distance. That makes sense? Now you could also take this approach that we did before. The initial momentum here is still 5. And then the final momentum, we don't know what it's going to be, but it isn't 0 and it isn't negative. So it has to be some other positive number, right, for the puck. Maybe it's moving at 3. So this isn't probably the best way to do it quantitatively since it sticks together, but at least we can get a feel for it this way as well. And so we know that in this case, 3 minus 5 gives me a -2. So if we rank them, this one's going to be the least change in momentum, therefore the least velocity.
So one of the points was to actually indicate that a greater speed would mean a greater displacement. So you'd have to actually say, like, if it's moving faster, then over 2 seconds, the angle will have.
Yeah, somewhere you need to state that fact. You can't make it an assumption. Yeah.
So you kind of have to like say all of your thinking.
Yeah.
You don't want to assume anything.
Yes, exactly. And that's part of the process of practicing these FRQs, is realizing, oh, I really need to say these things. I can't just think it, and it has to be stated. I really like on this one, I think this is the one, does it have the claim, evidence, rationale, example in the key? Yeah. That's what I would say your brain should do. And if you think it, write it. Like if it helps you process it, write it. Don't say, well, I don't need to write that. That's understood. Assume nothing is understood. Assume that you're explaining this to someone who has no physics background. Then you'll know you're going to make sure you include the important steps. And I really like that, even though the question said write it in a paragraph, they said, okay, here's my claim. Here's all the bullet points of facts that I know, and then you put it in a paragraph. And so just having those bullet points of facts, if they read your paragraph and they say, well, did they really understand that? Oh, yeah, they got a bullet point right there that says it when they were outlining their evidence. And you don't have to do that claim, evidence, rationale. That's not how you have to do it, but it can kind of help you organize your thoughts and make sure you don't leave anything out. Because anything that would help you in your train of thought, you should do. Now, you can't just write a bunch of numbers like this and assume they're going to interpret that. You need to then, like, this might just help you process what's going on. Then you got to put it into sentences and explain. Okay. But what I often hear students saying is, I just don't know where to start. Start here. Okay. It's about momentum, angular momentum. Find angular momentum. See if that gives you a clue. Okay. And here it says for this part B, well, which one goes the greatest distance? Well, the one going the greatest distance would be the one going the fastest. Which one of these has anything about speed in it? That one does. So use that one. Like, it's just kind of sometimes you just have to hunt for the equation that gives you a clue on how to start processing the question. All right. Any other questions for you guys about this problem? Okay. On the Unit 6 FRQ, well, on this one, there's another long one in here. It's a good one. It's actually another one about rotation and torque and angular momentum, and it's a really nice problem, one that I think there's a lot of really good content there. So I would encourage you to practice with that. The ones from Unit 6, if you're picking it up here, it's printed, or if you're looking at it online, it's got a couple pendulum problems, and then a spring problem. The first pendulum problem isn't a traditional FRQ, so that's why it doesn't say this is short, this is long, and it adds up to some weird number of points. It's more like a worksheet, that first question. But then the second one, the second example is an example of a short, and the third one is an example of a long, and they're both really good. So the only reason I included that first one, it's more like a worksheet kind of a question, even though it feels like an FRQ. It talks about the tension force in a pendulum cable, which is something they often ask about. So I thought it'd be good for you to process that. There are a few kind of weird glitches in the rubric for that one. So don't obsess about the rubric in terms of, like, it says it's worth 4 points, but then it only talks about 2. There's some weird glitches in that. It's like what they say is correct, but there's some typos, like there's a missing period and weird things in that worksheet. When you get to the actual 2 FRQs, they're pretty nicely formatted. But I like the question. I almost didn't include it because of those little glitches, but the question's a nice question. So, all right, so we got about 10 minutes left. Or sorry, about 15 minutes left. For all of you, for you guys in the Zoom, if you have questions for me or need help on anything, feel free to stick around and I'll be glad to help you. But if you don't have any questions for me and you understand everything, you're ready for Thursday, you can be dismissed a little bit early today and just start reviewing or work on that positive physics test that's due tonight. Remember, that's a huge part of your grade, so make sure you're working on that. But otherwise, you can be dismissed if you don't have any questions for me, and I'll see you Thursday.
I was wondering about, since I'm taking it online, how graphing is gonna work. Like, am I gonna be able to graph on there, or?
Well,
Oh,
the reason I
yeah.
chose the AP
Well, I
Classroom
think
as my
it's in-
source of
it's in
questions is so that it wouldn't have any that students would have an advantage on if they're doing it in the room. And so they won't have any
Let's go.
questions in this one that we're using that require that
No,
kind of step
change.
because you can't do it online.
Okay.
So, and that'll be the same if you, are you planning to
Oh,
take the
make it
actual
work.
one online in June or?
No, I think I'm gonna be able to come in person then.
Okay.
Let's
all right.
go.
Yeah, the one in June would be the
Why
same,
does it
where
keep
they wouldn't
talking?
have any of the graphing things in it. So,
Okay. Okay.
Does
Thank
it like
you.
what I'm doing?
You're welcome. And then for those of you here in the classroom, same thing, get about 15 minutes. If you need to work on positive physics, that's great. If you want to ask questions, that's great. If you want to work on some of these other FRQs, whatever you need to do, the time is yours and I'm available to help you meet it.
I have hacked positive physics.
You said you cracked it?
I hacked it.
Oh, you hacked it.
Yes. I made it say I got the right answer when I got it wrong.